Hi everyone, this video is on exercise 13 equation 7. So we have this curve and the equation is y is equal to 3x squared minus 2x plus 2. And so the graph of this function is bounded by the curve, the x-axis and the line x is equal to 0, lines x is equal to 0 and x is equal to k, where the area is equal to 8. So the area bounded is equal to 8. So area of the shaded region is 8 in this case. We want to find the value of k, so k is here. So in questions like this, we need to remember that if we integrate this equation between 0 and k, because that's where the curve and the region is bounded, then we will get the area. So let's write down the integral. So if we solve this integration problem where we have the integral of 3x squared minus 2x plus 2 dx, we will get the area. And in this case, normally we need to find the area, but in this case we are given the area and we want to find the upper limit of the integration. So we just integrate and then substitute and form an equation, and by solving the equation we are going to get the upper limit. So first of all, 3x squared integrates to just x cubed, minus 2x integrates to minus x squared, 2 integrates to 2x, and the bounds are, or limits are k and 0 is equal to 8. So now we substitute them. So we have k cubed minus k squared plus 2k, and then when we substitute 0 we just get 0. So minus 0 is equal to 8. Now we have this cubic equation, which is k cubed minus k squared plus 2k minus 8 is equal to 0. So, and the solution to this cubic is going to be the value of k, or the value of the upper limit. Now here we can use our calculators, because the calculators that are allowed for A levels, they can solve cubics. So one simple method is that you can just use your calculator to see what are the solutions. And if you use calculators, you will see that there's only one real solution, which is k is equal to 2. So there are also two other solutions, but they're imaginary roots, and they are not obviously part of A-level maths, they're in further maths. But the point is that the only real solution is equal to 2. So that's indeed the value of k. And even when you look at the curve, you will see that this makes sense. So this is one way, and the other way is just using the factor theorem, in which we try to guess the first solution. And so by kind of trial and error, you can also find the value of k, which is equal to 2. But so that's essentially the value of 2. So in order to kind of make this a bit more formal in the exam, so you can say k is equal to 2 by the factor theorem. So k is the value, because when you substitute 2 here, you would get 0, and that's the upper bound, or the upper limit.